All right, so next we're ready to talk about, this is actually section 7.2. We're ready to talk about inverse Laplace transforms. So inverse Laplace transforms. And the idea here is that what we've done so far is I give you the input function little f and you calculate capital F, right? You calculate the transform. But what we're going to do next is go the other way. I give you the transform, you give me the input function. Okay, so that's what we're going to do. So, for example, if we take the Laplace transform of 1 over s, what we have to think about is what's the function that we would have had to take the Laplace transform of to get 1 over s? And it turns out that that would just be 1. Okay, so it's a straightforward function that's on our list. What about the Laplace transform of, say, 1 over s squared plus 25? This is a little bit trickier. I should point out that because L is linear, then L inverse is linear too. So this is linear, meaning that if you take the Laplace, the inverse Laplace transform of a linear combination of two functions, capital F and capital G, this is going to be A times the Laplace transform of capital F plus B times the inverse Laplace transform of capital G. Right? So this is, again, linear in that sense. So if I were to look at the inverse Laplace transform of 1 over s squared plus 25, what we need to do is we need to think about what do we know about 1 over s squared plus 25? Well, we know that the Laplace transform of, this kind of looks like the Laplace transform of sine of 5t, right? Because the Laplace transform of sine of 5t was 5 over, I shouldn't have picked 5. My handwriting is bad. Let me go back, sorry. Let me go back and pick. Too late. I just got to write very carefully. So the Laplace transform of sine of 5t is going to be 5 over s squared plus 25. Okay, and that's not exactly what we have, but this is almost what we have. This is, let's see, I can put a 5 upstairs at the cost of bringing a 5 out. And so if I put a 1 over 5 in front times the Laplace transform of 5 over s squared plus 25, this is going to be 1 over 5 times sine of 5t. So what this says is that 1 over 5 sine of 5t is the function that you'd have to take the transform of. So this is 1 over 5. Again, I need to be much more careful with my 5's and my s's. This is 1 over 5 sine of 5t. That's the function that you'd have to take the transform of to get 1 over s squared plus 25. Okay, so that's the game that we're going to try to play here. One more. Let's say we have the Laplace transform of, so let's say we have the Laplace transform, the inverse Laplace transform of, say, 3 over s squared, over s squared minus 16. There's a few things that we can do with that, just to make it a little bit nicer looking. The first is that you can bring out the 3. So this would be 3 times the inverse Laplace transform of s over s squared minus 16. And this is going to be 3 times, let's see, s over s squared minus 16 was hyperbolic cosine of 4t. So that's going to be 3 times cosh of 4t. Okay, so next we'll do some derivatives, and then we'll move on to solving